So how and where did mob programming emerge? Where did it came to be? If you're into agile software development, you probably know the recommended practices like pair programming, working in iterations, continuous integration, and so on. But all these practices are more than 20 years old. And the question is, are these useful and valid practices for modern software development in the 2020s? The short answer is possibly yes, but we need to evolve and complement them. And that's where mob programming enters the stage. About 10 years ago, Woody Sewell was helping a team and a company to get back on track with their software development. And they were exploring new ways of working together. And the final result was what we know as mob programming today. And they must have done something right, because when mob programming was presented at a conference in 2014, it just took off and was adopted by many teams around the world. Similar approaches, similar ideas, older ones like pair programming with more than two from 2003, they just vanished, they disappeared. So the mob programming people did something right. A quick note on naming. And naming is hard, as we all know. Mob programming is often referred to as mobbing. Let's do some mobbing on this task. Let's do some mobbing on that story. But mobbing means bullying in many languages, and that's a pretty negative connotation. So people around the world are looking for better ways of naming that thing, that kind of working, like group programming or team programming. But that's not as catchy as mob programming. The latest idea is ensemble programming, which I like a lot. But don't think of a large orchestra playing exactly note by note, but more of a small band doing a jam session, having lots of fun and creating a smash hit. And maybe in a few weeks, in a few months, in a few years, we all call it ensemble programming or just ensembling. So now that you know what I'm going to talk about, let's have a look at the way your team might be working. Now, we have this huge new project before us, this huge task like this massive mountain. And we're going to climb this mountain one by one after each other. Problem is, one of us developers will be faster. They will advance quicker than the rest. They will be higher up the mountain, can see more clearly than the rest, so they will understand the problem better and thus advance even more. And the rest of us will get smaller and smaller, work in doubt and maybe fear. And in the end, this software superhero developer will extinguish all the fires in the project, and the rest of us will be left far, far behind. Now this hero developer will get or take all the interesting work, and the rest of the team, they will hide somewhere in a safe place. And believe me, if your company is large enough, there will be lots of hiding places, like strict processes or bureaucracy, lots of places to hide. But what if this hero developer leaves the company or he falls ill? What do we do now? Fortunately, the rest of the team is hidden in a safe place, so they can't be made accountable for all the problems. What's happening? I don't know. The superhero developer has done this. I don't know what to do. Please tell me, is there some documentation? And once this happens, you've got a problem, a big problem for the maintainability of your code, maybe even for the going live of your project. Fortunately, software craft people know what to do instead. Let's do pair programming. Let's climb this mountain together. And I've been into projects where most of the teams did pair programming, and we reached this goal together, and that felt great, and these projects were huge successes. So when you do it like this, it's great. But even pair programming, there's the danger that one pair is faster than the rest. So they will be the hero pair, and the rest of us falls behind again. This quick, fast pair will work on all the relevant topics, and the rest of us will get the tedious work, the work that no one else wants. And sooner or later, we're going to hide somewhere. We're going to split up, don't do pair programming anymore, or do fake pair programming. We just sit together in front of the screen, and that's wasted time. So what's the problem with these approaches where one of us or one pair is faster than the rest? You have to share their knowledge and their experiences afterwards. All the things that made them successful, you have to share it. And if you try to do this, that's pretty difficult. You can share knowledge via documentation, maybe, but to share experience afterwards is pretty difficult. Not so much what you can see, what you find in your Git repository, but what you can't see because it's been deleted. Why did they choose this approach and not the other one? Well, because they tried the other approach, but it didn't work. They deleted that code for a good reason. And now you've got the solution you'll find. And to understand this without the experience of building this together is pretty difficult. So why not build that knowledge and that experience together right from the start as the whole team, together with a whole team? And we call this form of true collaboration co-authoring and co-creation. And let me emphasize this. It's not only sharing knowledge, it's sharing knowledge and skills. Knowledge is not enough. You have to know how to make use of that knowledge, how to apply that knowledge. And sharing skills can be the more complicated part, or at least the more time-consuming part. So let's share knowledge and skills right from the start. Okay, how can true collaboration look like? Let's have a look at our pair of developers. And that's great. They're working as a pair together on a task. But during their work, a lot of questions arise, like we're new to this technology. We don't know what to do here. What's the best solution? What's good practice? Or we're new to this programming language. What's the idiomatic way of writing syntax in that language? Or did we understand the requirements from our product or domain correctly? Or should we do something different? Are we testing the right things? Do we make the right assumptions about our tests? And so on. And while they try to answer these questions, they can either wait for the people to come back to answer these questions. And if these people don't come back, they have to do research on their own. And that usually takes a lot longer than just getting an answer from someone. And if they can't get the answers and don't find the answers themselves, probably they have to replan their work for the whole day. So they're blocked, they can't work on their task. Maybe they have to work on a completely different task. What if we could get all the answers from all the people just when we need them, like all the ops people, when we have problems with our cloud deployment and so on, when we can get the answers from a product owner and the product owners available all the time and not just 5 minutes a day, when we could get answers from our quality specialists if we're doing test automation right. And if we couldn't just get answers, but we could discuss these questions with them. And they would talk to each other so that we go into the same direction and don't have completely different understandings of the problem. That is almost mob programming if that happens at the same time in the same space. So all the people that we need are working at the same time in the same space together on this one task. This might seem crazy, but let's have a look at what the original inventor and the early adopters have to say about mob programming. Llewellyn Falco, we'll get more of him later on, calls it getting the best, not the most from your team. So it's about quality, not quantity. Woody Zuill calls it all the brilliant minds working on the same thing at the same time on the same computer. We need all the brilliant minds, not only the developers, also the user experience people, the ops people, the product owner, everyone that we can get that will be helpful for solving the task at hand. And Joshua Kerievsky, one of the minds behind the modern agile movement, calls it continuous integration of ideas. And if you think it's crazy to integrate all the ideas of all the people in the same room, well, continuous integration of code was a crazy idea 20 years ago. Why integrate, why build and test every single commit? It's enough in the night or once a week. Why integrate every single commit? Today we're doing this. and maybe continuous integration of ideas will be the normal, the usual way of working a few years from now. We'll see. And pair programming is different. Mob programming is different to pair programming because it's got a different dynamic, and that often makes mob programming easier to adopt than pair programming. Like Alan Holub says, pair programming is like going on a date. It must match one-on-one. If it matches, it's brilliant, but if it does not, it can be exhausting and stressful, and rotating pairs can be difficult. Mob programming is more like having dinner with friends. It's easier, it's more relaxed. And if I've got a bad day, the rest of the team will cheer me up, and together we'll have a great dinner and make great software products. So mob programming might be easier because it feels better than pair programming for many of us developers. Now, how does mob programming work? And please note, there is no right or wrong. I'll show you some good practices that work pretty well for us, but you have to understand them, experiment them, and adopt them to your needs. There are no best practices, just some good practices, but they might provide a good starting point if you haven't done any mob programming before. So let's see. We go back to pair programming, and there is the notion of driver and navigator. The driver's doing the steering at the steering wheel, like the typing, fixing bugs, fixing syntax errors, and the navigator's got a map. She's got a plan what to do, and if our road is blocked right in front of us, the navigator can tell me where to go instead, while I take care not to run into the wall right in front of us or anything like this. And the most important aspect of these two roles of driver and navigator is to switch them regularly. If we stay too long in one of these roles, the other one just fades away. And this is the driver-observer anti-pattern. And if you don't take care, it's easy to fall prey to this driver-observer anti-pattern. One, the worker is doing all the typing and the talking, and the other one, the watchers, having a hard time, but finally falls asleep. And if it ever happened to you, you probably didn't do any switching of roles. And that's why switching roles is essential to successful mob programming. Rotation of roles, rotation of the keyboard for attentiveness. Switch these roles, pass the keyboard every few minutes, like every 5 or 10 minutes. This might sound crazy, but this is where most of the magic of mob programming comes from, passing the keyboard every few minutes. This really is the most important aspect of mob programming. And since it's easy to forget the time, we'll use a timer to notify us when it's switching time again. And you can use one of the hundreds of timer apps on the web. And again, I've assembled a list and attached them to the slides at the end of them, at the end of the slides. Most of the time, we just use a smartphone timer app because everyone's got the smartphone timer. It's pretty handy, so just use whatever fits your needs. And again, please pass the keyboard every few minutes. And it's good practice to start with 5 minutes when doing remote mob programming every 10 minutes, but do some experiments with it. There's a thumb of rule: the larger the mob, the shorter the time box, but please do some experiments with it. And the second important aspect is strong style navigation. The traditional idea of navigation is, I've got an idea, give me the keyboard and I'll type my idea while I'm thinking. And this stream of consciousness coding is pretty hard to follow, because while I'm thinking, you'll see my code change, and then I'll switch to this window and to that window, and I run away and I'll lose you pretty soon. So the traditional way of navigation, of being the driver, isn't suitable for mob programming. We're doing strong style navigation, a thing that Llewellyn Falco invented. We're doing strong style navigation instead. And it works like this. I've got an idea, so please take the keyboard and I'll explain my idea to you that you can type my idea. And while the idea grows in my head, you can wait until this idea has grown enough and it is clear enough, and then you'll take some, like taking notes, you'll put my ideas into code, but with your speed. I don't run away, I'm just thinking. I can't run away because you will be doing the typing. And this is the main reason that strong style navigation is the default navigation style for mob programming. You can do experiments with both, but strong style navigation is simply best for mob programming. So if you start mob programming, please start with using time boxes for the keyboard and using strong style navigation. And when doing strong style navigation, you're just taking notes, so you don't have to be a brilliant programmer. The rest of us is doing the thinking. They must be the brilliant programmers. And this way we can make use of all the brilliant minds, all the people, not necessarily the developers. A product owner can take over the keyboard and type our ideas into code. A user experience designer can take over the keyboard, because the rest of the mob is doing the programming, is doing the thinking, and the one at the keyboard, we'll call her the typist as well, is just doing the typing and not the thinking during her time at the keyboard. And why do we bind so many people for one task and put them at the keyboard? Well, because to get the most important task done first. And this is a really important idea of Kanban style working with limiting work in progress. We want to finish the most important task first. And if you're using this idea of Kanban style working with limiting work in progress, mob programming is a perfect fit, because we've got an implicit work in progress limit of 1. How does our typical mob session agenda look like? At the beginning, we agree for some guidelines for this next mob session, like what time box are we using? 5 minutes or 7 minutes, or let's do an experiment with 4 minutes. Will we have an explicit navigator like in pair programming? We can do so, but that's not necessarily. So the rest of the mob can be the navigator. And then we do a short, one of us gives a short introduction to the task. Short means maybe 1 time box, maybe 2, but once you realize that you're just talking, go to coding, put someone at the keyboard to just type in some code, then you get a clearer idea of what to talk about. And maybe then you can do the introduction again with the knowledge you gain doing some typing of code. So talking and planning is okay, but go into coding as soon as possible. And then we'll do discovery of the problem, a little bit planning, and implementation alternating as needed. The only thing we don't need to do is estimation, because we're already doing this task. Why estimate this task? Maybe to clarify things. Okay, we can do discovery and planning every time we need it. We're switching from implementation to doing some planning. Why not? But we don't need to estimate the task anymore. And that's a huge win for many of us, even agile developers. We'll take breaks about once per hour, like 5 or 10 minutes. And we found best working for us that our mob session should at least take 2 hours. If you take shorter sessions, it's hard to get into a flow. So 2 hours minimum is working best for us. And every now and then, or quite often, this 2 hours turn into half a day or maybe even the whole day, because we get things done and we're into a flow and we finish things. And once you're into this flow, you don't like to stop that mob session anymore. An important thing after that mob session, because so many people were working together, we'll do a short retrospective, like this start, stop, keep retro. And this will take about 5 or 10 minutes maximum. Like what we want to keep, what was good and what do we want to keep for the next session. Maybe we had some ideas what to start next session. And maybe some things happen that we don't want to do again. We put them in the stop section. Some teams like just to mention the good things, the keep things, to turn up the good. And that's really important to mention the good things. What was working really well that you can make it stronger the next time. But I found many teams who like to mention the ideas for the next time and even the bad things to stop. But please take care that the good things are mentioned in those mob session retros, and there will be good things every time. Some things are helpful for us, and that is noting down the guidelines that we gave us and all the insights that we found. You'll see some sticky notes attached to the screen in front of us, like some syntax elements. I think this was some Python object relational mapper that we used, and there were some functions. So we put them on the sticky notes. And everything else that's interesting, that's helpful for us attendees of the mob session. And use all media available, like the flip chart and the whiteboard and wallpapers and writable walls. And you can write on all walls. Use the ones that you can clean afterwards. I think your boss will like this best. And of course, we'll use lots of sticky notes when working co-located. I'll come to remote mob programming later on. One question that arises all of the time is, should we do mob programming all of the time, 100%? And that's possible, absolutely. There are teams around the globe who are doing mob programming day to day, all the time, all of their working time. That's definitely possible, and they've got huge successes with it because they're just finishing the most important things. They're into a flow of finished value that we can deliver to our customers. But it's definitely not necessary. You can use mob programming as a tool. You have to learn it. You have to do some experiments with it, and then you can use it whenever it's helpful to you. It's just a tool. But one thing you can do 100% is to give 100% for the most important task. But not everybody has to be there 100% of the time. And that's what we call a dynamic mob. You can come and go every time. For example, we're working in a mob session and I've got to go to a meeting. Okay, then I'm leaving the mob, go to my meeting, but the rest of the mob is large enough to still work on our task. And when I return after my meeting, I'll watch for a few minutes and then can join the mob again, maybe pretty soon as typist, because the rest of the mob still knows what to do and I just have to type in their ideas. So this way, with a dynamic mob, you can work on your most important task until it's done at the end of the day, but not necessarily all people have to be there all of the time. And that's really, really useful for a way of working in our home offices. And when you work as a dynamic mob or as a mob and you start a new thing, it's a good idea to start together. Usually we plan our activities, estimate and plan our stories, and then we'll split it up into tasks that we can work in parallel on. That's problematic because when we work in parallel and then come back together and try to join all these pieces, there's a great chance that they don't fit together. Why not start together instead? So we start working on our task and everyone knows the basic ideas, like setting up this Spring project or setting up this AWS account. And what do we want to do in this account? And once we know this, we can split up, if you really like, work on the parts of this. And when you come back together, it's a lot easier to understand the different pieces, the solution to the different pieces, because we all were there when we started working on our story. Even team decisions are easier because usually you have more than one idea, and mob programming says, well, try them all, because there's a great chance that trying all of your ideas, not 100%, but say like we'll do some coding 20% for each idea, and then we can do a much better decision which idea to follow. And there's a great chance that this way will take less time than discussing one idea to death and then doing a decision and finding out in the end that this decision was just not working and you have to start from scratch again. So How can it work? Like this first idea, the mob's working on this first idea, and that one's not working, so we have to dump that code. Deleting code, dumping code is difficult. We have to learn to let go of our code, but you can learn that, and it's easier to let go of our precious code when we do this as a group decision, as a team decision. So the first idea is not working. The second one, we try this. Yeah, that one's working. And if our team is running out of time, we'll have a working solution that we can deliver to our customer, making her happy. But our team's got some time left, and we'll try the third idea. And that one's not working, or maybe not working as good as the second idea. So we go with the second idea this time. And I call this do and decide. We'll do some discussion, but then we go into coding and try every idea just enough that we can do a good decision whether to follow this path or not. But then we've got a decision that everyone commits to. And we've got not this discuss and defer. We discuss it to death, and then we defer it to the next meeting, and then to the meeting afterwards, and so on. We'll have working code, and that's really, really great. So now that you know how to run your mob sessions, what does your setup in your room look like? Usually we have a large screen in front of us. We've got a whiteboard and flip chart, and here we've got an explicit navigator and a driver at a separate table. There's the laptop or the PC, the computer, the driver's doing the typing, and we've got an explicit navigator, maybe showing some code at the large screen, guiding the driver, the typist. You don't need this explicit navigator. The rest of the mob can be navigators too. Try some experiments with it, which setup you like best. The rest of the mob can do some research. You'll often see photos where only one PC, one laptop is, one computing device is in the room, but the rest of the mob can have tablets or their own computers to do some research, to help the navigator, to help the typist. But commits for our code, the coding is done only at the driver's seat. And of course, we'll rotate all these roles. Helpful for us is to have a lectern, a standing desk at the driver's seat, so that the driver will not sit down but stand at the computer. And this way we're moving people and not just the keyboard around. Moving people is really great for attentiveness. And helpful is, at least if you start to have a host or facilitator, a moderator for your mob session, to see when you're stuck, when you're communicating in an unhealthy way, just a meeting moderator, facilitator, and that person doesn't necessarily have to be a good developer. No, you just need someone to take care of the time and help you seeing things that you don't see when you're in the development tunnel. Right, and when this was working really, really well, and many teams were adopting it, then came Corona. And it wasn't a good idea anymore to work together in the same room at the same keyboard. What to do? Fortunately, a small team that was doing remote mob programming for many, many months had written about their experiences last year already, and they've published their insights and their really valuable hints and tips on their website, remotemobprogramming.org. There's even a free ebook that you can download, and I recommend you really have a look into that page and into that ebook, because it's really useful for remote mob programming and for remote work in general. Remote mob programming is different to how distributed teams usually work. If you have a look at the remote manifesto, it says we prefer asynchronous communication over synchronous communication, while remote mob programming says work at the same time. We need the magic of all the people in the same room. We need them at the same time in the same virtual room. This is where the magic of mob programming happens, the sharing of knowledge and skills. And We need this for remote mob programming. That makes a difference from the usual way of working for distributed teams. And when we're working at the same time, how do we see each other? I think this one's easy. We're doing some screen sharing, and the remote mob programming people decided to leave their camera always on, that we can see each other all the time. I can see when you're leaving your place to get some water for you or anything else. You have to answer the doorbell. I can see when you're not at your seat, not at your workstation, and I can see when you return. It's like in a real office, we can see each other. And use whatever tool works best for you, like Jitsi or Slack or Zoom or Whereby or Microsoft Teams. They're all really great tools. They work. One thing the remote mob programming people talk about, and they published this, is you should be remote everybody. As soon as one of you is remote, everybody should be remote. So it's probably not a good idea to put part of the team co-located in some office and only few of you remote via screen sharing, because the remote people will be left behind, most probably. So if one is remote, all of us will be using screen sharing, headsets, microphones, and so on. How to code together. The remote mob programming people developed a small tool for GetHandover, and the idea is to be able to pass the work in progress as a temporary Git branch to the next driver, to the next typist. You can download the tool at mob.sh. And the basic idea is to say, I'll start this, I'll hand over mob next to the next typist. And at the end, when the work is done, all the intermediate commits or the temporary commits are squashed into one commit with a meaningful commit message. And that's pretty handy. There are lots of other tools for remote stashes on the web. Just have a look at them and use whatever works best for you. One cool new idea, and I think we're into our last 5 minutes, so that's okay. A cool new way of coding together is to share your IDE. And it works best with Visual Studio Code. Yes, Visual Studio Code and the Live Share extension. This way, you can work on your locally installed Visual Studio Code. One of you is sharing your code, and the rest will just connect to your session. But every one of you is working in your locally installed Visual Studio Code, and this is working really, really well for coding. And just recently, JetBrains released Code with Me, a similar plugin for IntelliJ, and for coding. This is great already. You'll see that it's just been released, and there are some rough edges that still need to be worked on, but that's really, really promising. And another tool like Code Together, they just released a new version that you can share your code between different IDEs. Like someone with Eclipse can share his IDE, and someone else from IntelliJ or Visual Studio Code can join this Code Together session. And this way, you don't have to push and pull via a remote repository, but you just share your running and locally installed IDE. This is really great. Other possibilities include Cloud9. This is the online IDE of AWS. And for example, Eclipse Theia, the online IDE on Gitpod. How to draw on a whiteboard? Why should we draw? Software development is so much more than just coding. It's about drawing together, visualization. And we use Miro and Mural for that. There are other tools. Just use one of them, and you cannot just place stickies there and the others see in real time these stickies appear or disappear. We can draw on that surface, and that's really great. If you have a tablet and a pencil, you can do your drawing that you used to do on your whiteboard in real time with these products. You can try them for free and choose which fits best for you. How to keep track of time? You can use some smartphone timers, and there in the chat someone said there is a plugin for IntelliJ, but it's not for remote mobbing. At least it's not suited that well as far as I've experienced it for remote mob programming. But we use the web timers instead, like MobTime or Cuckoo Team. You can create a timer on that web page and share that URL so that every mob session member can open that URL and has the timer running on her web browser on any device that you like. This is the way that we try to keep track at the moment in our remote sessions. And one great thing that we experienced a few weeks ago was how to find my next mob session. When doing remote mob programming, you can't just walk across the floor and see who's working on what. And just recently, I've been to a team, two teams actually working on the same product, and they've got a mob sessions channel in their Microsoft Teams. And in this mob sessions channel, every mob session opens video conversation. So you can see who's working on what and which mob session you'd like to join. And some of them even start a single video conversation with one person in it in the morning that others can see, oh, there's someone working on that story. Let me join him or her and we can work together on that task, and others will join or leave that mob when they've got to go to a meeting. This way we can see who's working on what and and do work on tickets that we can contribute and help, or work on tickets that we'd like to learn, because we can see that others are working on that and that we can learn these technologies. But whether remote or co-located, there will be mobs of two, there will be pairs, but what we've experienced, your pair programming will get better because you learn how to switch roles, you learn how to do strong style navigation, and this way even your pair programming will get better. There's a difference between being driver and being typist. When doing pair programming, being driver can really be stressful because it must match one-on-one. And if the gap of knowledge and skills is too large, it can easily be stressful. When doing mob programming, you relax at the keyboard. You lean back and wait for the navigators to do the thinking. And once they've done the thinking, you keep the notes, you keep the minutes. You just take some notes in code. So it can be really relaxing being the typist in mob programming sessions. And that makes it easier for introverted people to join these sessions. It might sound crazy or funny, but it's our experience. It's easier. It's they feel more comfortable with it because they don't have to do any typing. They just take notes when the others have done their thinking. This can be really relaxing compared to pair programming. And this way you can do other tasks, not only pair programming, but also not only mob programming, but also mob testing. You can become a better tester and a better developer by doing test sessions guided by a quality specialist. So, last few slides, why is it working? I think I've experienced that mob programming is working because it's making our implicit, our tacit knowledge and our skills visible. All the things that we usually don't talk about or don't show if we're not being asked. In mob programming sessions, I can watch others while they are thinking. I can see how they are solving problems, what they're doing. I can experience the way they're thinking. And I can do this thinking myself because I can be guided by the other developers. And that's really a great way of learning new things. And it's different to meetings, the mob programming, because in the end, you'll have working, hopefully tested and shared code. And this makes our customers happy. If we've got something working and if our customer is happy, we usually will be happy too. So we will deliver better software in the future. So mob programming is not only about learning, but also about delivering working software. And this is really a great way of working together, of doing software development together. So time's nearly over, but I think there are some questions. I'll stop my screen sharing and maybe the moderator can help me to sort out which questions to answer first. which questions do you have? Let me have a look at the chat. I'll start with the latest ones. How often do you do mob programming? Me personally, whenever I go to a team, I try to do mob programming sessions with them. And there are teams who want to do it once in the morning, once in the afternoon. That's great. I've got other teams, they're happy if they can do it once a week. But what I've learned is do it regularly, at least once a week, to get used to this technique, to get used to this tool, that you get the idea of when to use mob programming. But you don't need to do it 100%. Okay. The cost. I skipped the manager slides. You'll find them at the end of my slides. What about the cost? The question is, what's more costly? Of splitting up and letting developers do everything in parallel, and then it doesn't fit together, and maybe all the developers, most of the developers have worked on the wrong things, and then you have to integrate pieces that don't fit together, or you have certain people working together, and it doesn't mean your team of 30 people. Our mob usually has a size of 4 to 6 people, and it's easily possible that letting those people work together and finishing their things, that it reduces cost compared to letting them work in parallel and integrate very late in the game. Mob programming is early integration. You get early feedback if your ideas are working. If you let developers work in parallel, you get late integration, like working with pull requests and the changes and all the refactorings that are necessary and the discussions and the endless meetings. When mob programming will work together on this task until it's finished, and all the discussions and the refactorings, what we usually do asynchronously, is done at the same time. And my experience is that this takes fewer time, it takes less time than working in parallel and trying to integrate this later on. Okay. I think to the moderator, I think I've got, can I use 4 more minutes? If that's okay. And then
let's do one more question and then please come to the end. So the next speaker is already in the room.
Okay. Okay, I'll take the last one. Sorry for the very first questions. Which task to start with? Actually, I wouldn't recommend starting with the most complicated task that you can find, but also not with the most trivial task you can find. Do take a task where at least some of you are familiar with. Like, for example, let's set up a new microservice and we're using Spring Boot with it. And some of your developers know how to do this, 1 or 2. And the rest of the mob, say 3 to 4 developers, don't know how to do this. Then you've got a task that's not too trivial, but you've got some reasonable work to do on. And something in the middle should be, is my experience, that it's working best for your very first mob session or your first mob sessions. Okay. So that's it from me. Thank you. See you and bye.